All right, guys, are there any questions on any of the assignments thus far? All right, guys, what we're looking at today, there's two main things we're looking at today. One of them is circumcenter and the other is incenter. Now, the circumcenter of a triangle is equidistant from the vertices. So this point P is equidistant to the vertices, or the angles. So that means these three line segments here are going to be congruent to each other. And they're going to be, if it's going to be an incenter, it means that these lines here are perpendicular bisectors. So they cut the sides in half and form a right angle. And these sides are all going to be congruent. But the big part is that with the circumcenter, that point P is the circumcenter, and it's equidistant to the vertices, or to the angles. So that these three line segments here are going to be congruent to each other. So let's look at our first example of this here. Now point G, this tells us here that point G is a circumcenter. Okay. Is a circumcenter. So that means that the distance from this point to the angles are all going to be the what? Same. Now it tells us that CG is what? 9. So BG is going to be what? And AG is 9. Because it asks for BG, so BG is 9. So all three of these lengths are going to be the same. Because it is a circumcenter. Questions on this here? Now we don't know much about the other segments because we could find this line segment because we do know two sides of the triangle, and this is a right angle. So we could use the Pythagorean theorem to find the third side. That's the distance from A to this point here. Now what would the distance between, we'll just call it point E. E to C would be 8, and the whole thing would be, yeah. I don't have the gestures turned on. So this here, point G is still a circumcenter. So that means that CG is what for this here? Because it told us what it is. Now what is BG going to be? And AG, it's just this length here. It doesn't, we can't really say anything because it's a circumcenter. It doesn't give us any information. Now this line segment, and this line segment don't have any relation when it's a circumcenter. But they will come into play later. Any other questions about this here in our circumcenters? Yes, sir. Yep, because since this is a circumcenter, it's saying that the distance from this point to the angles will all be the same. Because when it's a circumcenter, these lengths are the same. Yeah, so circumcenter theorem is really saying that the circumcenter of a triangle is equidistant from the vertices, or the angles are going to be the same. And since both of these are a circumcenter, well, these distances will all be the same. And the same is true for these here. Now the note sheets are a little bit out of order because I believe there's another example problem before this here, and we'll go back to it here in a minute. The other one that we have is an incenter. The incenter of a triangle is equidistant from the sides of the triangle. So from our incenter, it to the sides of the triangle will be congruent. So if it's an incenter, it's going from that point to the sides. A circumcenter is going from that point to the angles. So it's saying that these three here are going to be congruent. Now, one of the main ways that we'll know that it is a incenter is because the other three lines are going to be angle bisectors. They're going to cut the angles in half. So when we have three angle bisectors, the lines where they meet is at the incenter. So we look at this here. This is going to be an incenter. Mainly because it says, or the angle bisectors of triangle XYZ intersect at point P. It tells us. So that means that PS, PU, and PT are all going to be congruent, the same. Well, what is the length of PU? So what's the length of PS? And the length of TP is 2. Because they're all going to be congruent to each other since it is in center. Any other questions on this here? We ready for the next one? So this one here, you might have to go back to get to this problem here. Now this one here, we want to find the length of NF. Now we know that point N is an incenter, mainly because as we see at each of the angles, they are bisected, they're cut in half, because each angle on opposite sides of them are congruent. It also says up here, using the incenter. Now it did give us some information. It tells us that ND is 5x minus 1, and NE is 2x plus 11. And we know that all three of these are going to be equal. They're congruent. They're the same length. So if I could find the value of x, I can find the length of all three of these lines. So what can we do first to find the value of x?
5x minus 1.
Plus 11, yes. Then what can we do next? Solve for x. What would we do first to solve for x? We can subtract 2x from both sides. And if we subtract 2x from both sides, yes. And then add 1 to both sides, which tells us that.
3x equals 12.
Divide both sides by 3, which tells us x is equal to 4. What do we need to do next? Plug it in. So we do 5 times. So we can do 2 times 4. So 5 times 4 is? Minus 1 is? If we did the other one, 2 times 4 is? 8 plus 11 is? 19. So, and it asks for NF. So what is the length of NF? Now, it is good to go on and plug it into both because these lengths should be the same. Now, if we got the correct answer, it will give us 19. Now, say if we did 3, if we got 3 as the answer, well, 5 times 3 minus 1. 5 times 3 is? Minus 1 is 14. 2 times 3 plus 11. 2 times 3 is? Plus 11 is Well, they're supposed to be equal, yes? Well, if we plug them into both and they're not the same, that means that's not the right answer. We have to find a different value of x. Most likely there's an error that occurred. So plugging it into both and you get the same answer is a good way to check to make sure we got the right value of x. Because if it's the wrong value of x, it will give us different values. Any questions on this here? Let's look at the next problem. And yes, these do look the exact same, but we do now have a part B. Already filled in part A because NF is 19. Now, part B is asking, can NG be 18? What do we think? So could it be 18? Into G. So really we're looking at, say, this triangle here. Now this here would be a right angle. So I'll draw it out over here so we can kind of see it. So this would be a right angle. We have that this is 19, and we want to know if this could be 18. Because it's opposite the right angle, yes? And we had a special name for this side. It is the hypotenuse. And the hypotenuse is always what? The longest side. So could this side be 18? Because the other side is 19. So this would be, no, it would have to be bigger than 19. Because the number is too small. We can't have a hypotenuse that's less than one of the two sides. So no. Any questions on any of this here? P is the in-center. So that means that these three lengths are the same. PJ is, PL is, and we want to find the value of PK. Well, we need to find the value of x first to be able to find the length. So what can we do? Then what can we do next? We can subtract x from both sides, which will tell us that. So we can add 8 to both sides. Guys. So 3x is equal to 15. Divide both sides by 3. And x would equal 5. Then we would need to do what? Plug it back in. So we can say 4 times 5 minus 8 would be 20 minus 8, which is 12. We can do it with the other one as well. 5 plus 7 is 12. So the length of PL would be 12. Any questions on any of this here? Yep.